All right. So later on in the lesson, I'll cover what zeros are and what solutions are and what x-intercepts of quadratic functions are. But first, we're going to tackle how do you factor x squared plus 4. Okay, so they're asking us to break x squared plus 4 into its factors, which means that they want us to write. So if we had a parabola, a quadratic function such as ax squared plus bx plus c, for example, its factored form would be probably dx plus e times fx plus g, where d, e, f, and g are coefficients, okay? So that's what they mean by factoring. Another reason why we factor is that we can find the zeros, and the zeros relate to the factors in a way that I'll describe right now. Okay, so to factor this, we cannot use the traditional cross multiplication method to factor it, so we're going to use a quadratic formula instead, and I'll get into the reason why very soon. Okay, so the quadratic formula is described as x, so the values of x equals plus or minus b times the square root of b squared minus 4ac divided by 2a, where b, a, and c are the coefficients of our basic quadratic equation. And these this formula helps us to find the values of x, which are the solutions to ax squared plus bx plus c equals to 0. Okay, so this quadratic formula helps us to find the values of x that make this equation equal to 0. Okay, so we're going to do this with our own example here. So we see here that our function here is x squared plus 4 equal to 0, and we're going to try to find the values of x. Okay, so our coefficient b is not there, so it's 0 plus or minus the square root of b squared, so 0 squared, minus 4 times the coefficient of a is 1, right? For ac, so c is equal to 4, okay? Divided by 2a, so 2, okay? So we see here at the end of the day, we get the square roots of negative 16 divided by 2, plus or minus, okay? Now we ran into a little bit of a problem here because we can't square root negative numbers. Using mathematical logic and understanding our understanding how the square root function works, the square root function cannot produce a result with a negative number. Okay, so we have to use imaginary numbers to circumvent this. Okay, and so another important property is that I, which is the imaginary number, is equal to negative 1. So in this case here, we can see that we can write root of negative 16 as the root of 16 times I, right? So we broke it up into the root of 16 times the root of negative 1, and we know that I is equal to negative 1, our root of negative 1, so do we have this now? So now we know what the square root of 16 is a perfect square, so now we have the answer that our solutions to this formula is plus or minus negative 2i. Plus or minus 2i. Okay? So with this in mind, we now have the zeros, and the zeros relate because they relate to factors as such. So now we can break up x squared plus 4 equals 0 into x plus 2i times x minus 2i. Okay? So we can see here that when x equals 2i, this bracket will equal to 0, and anything times 0 is equal to 0. And when x is equal to negative 2i, this bracket here will equal to 0. So this bracket here will equal 0. And 0 times this is equal to 0. So that's how the zeros relate to the factors, okay? So by finding the factor form, we're able to find the zeros that make this equation equal to 0. So that's why we call them zeros. Okay, so these are the factors of x squared plus 4. And we see here that the factors, or the roots, are actually just complex numbers or imaginary numbers. And I'll get into the reason why later on into the lesson, because we're going to cover what a discriminant is and how it gives us information about the solutions to our quadratic equation. Okay, so the solution is correct. Good work.